to lead to the formation of the new vortices southeast of the original vortices. And I think Yiqing Wang and Holland argue that this low-speed wave train usually is quite elongated, so it can be formed circular by some diabatic heating. But even my argument was pretty much with a monsoon background flow and the axis utilization dynamics, it can also leads to this form every 7 or 8 days. But all this appear to be important with monsoon background flow. So I think I'll just pretty much, this is a lot of things should be ongoing and needs careful studies. But surely this is a lot of people say about this. Through the interplay of all this leads to the tremendous rainfall. I think there's to understand the whole problem, understanding the problem to be solved, maybe just as important as solving the problem. I think the monsoon, typhoon, mesoscale convection, and multiple scale interaction should be, they should study together more closely. And I think the terrain effect on the initiation of the precipitation and all these kind of detailed things, but also I think why there's a large variabilities in the translation speed. And finally, this is I wish I can learn more is you look at this all these ranges, looks like something happened after the year 2000. So what is the annual or is even decadal variations? So that's all I have. Thank you for your attention.
Okay, we have time for a few questions. Let me start by asking, in fact, in the last paper or so, the convergence between the cyclonic flow from Morakot and also the southwesterly flow give you this very strong connection. Now, what do you know? Has anybody looked at the role of this air coming out of China? How that interplays with the moist southwesterlies?
I don't know.
Or maybe somebody can.
Yeah, you're saying the air. What's might be? Yeah.
So there are actually two flow patterns. One is coming out of China.
Yeah.
And the other one is this very moist southwesterly.
Yeah. And look, I think here also very strong westerly, as Benjo talked about this morning. I don't know. I don't have the immediate answer to this.
Russ always has a question.
Not always, but I'm sorry I came in late. Somehow I got the wrong time, but and maybe you explained this. But how do you really define the translation speed, especially when it's crossing the?
Oh yeah, I explained that. It's really I try to using the landfall point and then try to carefully find the departure point and using the linear distance divided by duration time. That's how I did in these calculations. So because I don't know really what's happening, you know, there's a strange type of curve or wobbles of the path in the land, which I don't know, but I just using that as a calculation of translation speed. This is how it's done.
At least in the model, you find a decoupling of the wind circulation and the sea level pressure.
Yeah, this is all from observations. Yeah. So the departure point is, yeah, I have to be careful about, there's a certain inaccuracy in it, I would say. But originally the landfall point is quite accurate. But still, I think this is using the linear distance and try the best, you can get probably just one indicator, one index of speed.
If you go to a next slide or so, where you say, okay, if you say there's large variability, if you eliminate the one at the top, really is there that much variability?
Well, this is what I plot here. The variability I mentioned is really for the whole storm. But what I plot here is the most heavy pounder, just a few storms. This is something usually we're counting in Taiwan, the local people say this is a 10 most devastating storm. This is what I plot here. So this is not everything.
So you're saying that's a common signature, and that's just an unusual one that's up there?
Yeah, for this, so you can see, for these heavy stones, it looks like most of them are going down, become slower. That's why I'm saying, but if you plot all the stones, surely you'll be fractured. But even with the one I was trying to say is that even you know it's slow, you have to be careful, but still, there's a very wide variety, variabilities in terms of the precipitation. But even with this one is so low, I was just saying that it can also hurt a big city very much.
Yeah, so just that exact point. So the cases where you do have a slow translation speed, but also a relatively small cumulative rain,
Yes.
what are some of the other mechanisms that would explain why you don't get much rain in that situation?
This is a very weak typhoon, and it just turned out that the heavy precipitation just occurred in the Kaohsiung city for 3 hours and pounded out this amount of rain, and that caused a tremendous loss in the Kaohsiung city.
Yeah, could it also be just related to the amount of moisture in the environment of the tropical cyclone itself, like that just is a drier storm, quote unquote?
Sure. This like I said, the translation speed is not the whole story because it's a wider variability. So there's other type of metrics we look into.
Yeah, other contributors to the variance.
Yeah, maybe this is no southwest. So this is something I think there's a more careful study needs to be done.